Well, good morning, everyone. Welcome back to the Daily Grind. This is a podcast by Cutting Tool Engineering Magazine. We are here at Lafayette College Engineering once again. If you guys noticed, a little bit of a different background, but we have the cars behind us. So many thanks to the Lafayette EV Club, Ben Franco, Maria Romashenko, Bram Halpert, and Kruth. I can't thank you guys enough for making the space for the show today. As I was explaining to our guest, our usual backdrop, the machine shop, is being heavily used and it's not very quiet. So I wanted to give a good place to concentrate and spotlight our guest. Today we have Brad Kmieciak of Guhring Tooling. We want to thank you for taking the time to join us. So one more thing about Lafayette is we have an unparalleled engineering curriculum that's going to put you ahead of the pack. Should you or somebody you know have a high school age kid looking for a place to go, we encourage you to say Cur Non or why not and join us here at Lafayette. It is the best place to be. So with that, let's hop right into our interview. And as I like to say, let's make our first cut of the day. So as with all my guests, first we do a brief backstory. Who are you, your title with your company, and what do you do for them?
Hi, my name is Brad Kmieciak. I am a technical application specialist for Guhring. And a little background on myself. I've been in the machining industry for over 20 years. I started off, my first job ever was in a machine shop. I needed a job so that I could drive a car, and I got a job sweeping the floors. And that was in high school. After high school, once I graduated, I got into the apprenticeship program with them and got my journeyman's card in machining. And then I have done a lot of different things in the machining industry. I've worked for a machine tool builder as an applications engineer. I've been a manufacturing engineer. I've worked I've ran large 5-axis CNC machines. I've also done field machining for a little while, it's just a large, a lot of different things, a lot of different roles I've done inside of the machining industry. So I did want to point out, I listened to shout out to the podcast you did earlier, I believe, with Terry talking about, the future, and there's a lot of opportunities for someone looking to get into this type of career, not necessarily just running a machine, but once you have that foundation, you can really grow and do different things. So
I want to thank you for that little shout out to Terry and advocacy for the trades. Brad, as you know, and as my loyal listeners know, I am a huge advocate for all the skilled trades, and I really feel that they need to have the ranks replenished. So thank you for that. As to your company, your title with your company, you said you're an applications engineer?
Yeah. Technical applications specialist. So I would say my focus right now would be for our milling tools. But if you have any application questions for pretty much any tool, I'm here answering the phones or emails through the tech support line, or if you call in, whether you need a tool select or, a suggestion for what tool to use for whatever application you're doing, or if you have, you're running into issues.
Excellent. Your company, Guhring Tool, what is their specialty? What's their bread and butter?
I would say that our bread and butter, the one of the things that is always, like gets us in the door a lot of places is our drills. It's, Guhring was started in, I think, 1898. And they started making drills, and, it's still probably one of our strongest lines. And just in general, it's going to be carbide round tools. Guhring has a full lineup of carbide tools and round tools. We control our own carbide production. That we are cutting tool companies, so that allows us also to kind of control specific carbide grades and things like that. That's kind of where we are. I would say sets us apart. We also this is a huge global company too, so there's a lot of we're in I think 70 something countries, I believe, and we have a lot of manufacturing facilities all around the country. We're based in Germany. I work in Wisconsin at our U.S. headquarters, which is also a manufacturing facility where we're going to make a lot of our special tools and things like that here for the U.S. market.
So we're going to touch on custom tooling in a moment, but just to further Brad's point, is word of mouth spreads really fast. I was on LinkedIn the other day promoting the show, promoting today's episode, and you had said 70 some countries are in. Japan, India, Turkey, and one other one aside from us immediately reached out and were all about the big names for the props for the company. So yes, you guys are everywhere. I did not realize it.
Everywhere, all over.
So thank you for everybody for listening and reposting. Guhring's approach to custom tooling. So did you say that the United States facility is manufacturing for custom tooling?
Yeah. So for custom tooling for our specials, a lot of that is going to be manufactured here in the United States. We do manufacturing currently in Wisconsin and in Michigan, and these are both going to be places where we're going to do special tools and reconditioning. And there are still some product lines where the specials are going to go back to Germany and get produced there. But a lot of your main, like your drills, your end mills, a lot of these specialty tools are going to be designed and manufactured here in the United States for this market, for the United States, just to make it, to speed things up and, just be able to provide, a quicker turnaround and, a little bit, there's not that disconnect to go back and forth, to Germany and things like that. So just for our custom tools, it made more sense to do that here.
Excellent. So I actually have a custom tool that Lafayette EV, or it was Lafayette Motorsports at the time. So this is back in let's see, when did we do these uprights? This is a 2016 vintage. So I actually have the part here. I'm going to show it to the audience. This is our wheel uprights. This goes inside of our wheel package. It holds the wheel hub, the brakes, the suspension, and the steering all in one ingot. And to do this, it was out of 1.5 inch thick material, and we needed a small enough end mill diameter to make sharper corners for things to sit in. And we were having the damnedest of a time finding something. And I actually sent one of the students, so our normal supplier is MSC, and everybody uses MSC. But they had actually sent us to Guhring. The rep that we had was very familiar with Guhring tooling, and they came back to us with a 3-fluted 1.5 inch reach end mill that saved our bacon and got us to competition on time. That team did pretty well that year. So there's just one little story that Guhring helped out, and Guhring can do the same for you. Thank you guys for that.
But
like I said, I wanted to showcase exactly what you guys did for us. On a somewhat related note, but not necessarily Lafayette, some of my loyal readers and listeners will know I joined up with a race team for. Have you ever seen that crap can series, 24 Hours of Lemons?
No, I haven't. But it sounds like fun.
It's a portmanteau on that super high, spec racing, but for cars that cost $500 or less. So you can imagine the attrition. So we actually use some of your tools to make some of the parts for our car. So you guys are both stationed everywhere, and you're getting everywhere. So I wanted to also point that out for our listeners. Let's go into the tough stuff. So we talked slightly about hard milling, and I touched on this really big last week, but let's go into what Guhring offers. What does Guhring do for those looking to do like die work or mold work where you're cutting stuff that's heat treated?
So we, within the last couple of years, we've come out with our G mold line, which is it's actually all tooling geared towards uh, making that die and mold, making those die and mold components, tools, and this was uh, not just adding coating to what we originally had. This is new geometries. This is, a full new line of like a torus end mills and different things like that, specifically for doing that type of work. As far as hard milling goes, inside of that G mold line, we have it broken down in our names. Whether it's per, it'll be an end mill for 40 up to 48 Rockwell. It'll say 48 in the name. It's over 48. We have a 55, and then we go up to 65 Rockwell. Those tools are all going to be, specifically for cutting hardened steels. They're going to have, like I said, the geometry, the difference between the 55 Rockwell tool and the 65 Rockwell tools. You're going to see the rake angle is going to change on the end mill. That's something to keep in mind when you're looking at what tool is going to be for what. We kind of try and spell it out, like I said, to make it easier. And then, like I said, those are really the things that you're going to have to see from, or you can see from us, is our G mold line for hard milling. That's our newest line and the best we've come up with for that.
Now, just a quick plug for yourself. Can people reach out to you directly, or do they just call Guhring to talk with an application engineer for specifically this kind of thing?
I mean, they can always reach out to me. They can call Guhring and you can ask for me. I'll answer the phone. If you email tech support, I'm going to be there to answer those kind of questions. I can also put you in touch with a territory manager out in the field that can help you decide which, look at what you're doing and then suggest tooling that way. So tech support at Guhring.com is a great way to get a hold of me. And then, like I said, I can either answer your question directly or I can put you in touch with someone who can answer those questions.
Thank you. So now, in my LinkedIn post promoting the show, I made a little bit of a pun that we're going to gnash the throttle on high speed, high efficiency. Yeah. And that's where I really want to spend a good chunk of today. Guhring, what do you guys, have you come up with an offering, or do you have certain tools that are great for low step over, high feed, chip thinning, getting that material out of your way?
Absolutely. That would be our RF 100 speed series. So those are going to be all end mills specifically designed for high efficiency milling. They're going to be like 4, 5, and 7 fluters, and they're designed to do like a long length of cut, a light step over. The 5-speed end mill is a really good one if you are you want to do some of that high speed machining. We also have tools that the 5 fluters will have a stepped core, so you can use them when you have the opportunity for high speed machining. But the core down at the bottom still allows you to do some full slots too, because it's got a little more room at the bottom to allow that chip evacuation for a lower depth of cut. But then once you're able to get in there and start doing that high speed machining, the core is thicker up in the top for those light cuts.
Okay.
I have to get in and give people a little background on what we're talking about with high speed machining. I'm just going to share my screen here a little bit and just start talking about what high speed machining is, how it works, why it works the way it does. And then I can, I can talk to that. let's see here. Let me get this up. And let's see. Now it's not showing up. Spinning on me here.
Why is it the minute you need technology, it?
Oh, I know.
Tries to make a break.
All right. Well, you know what? I'm going to keep going. We'll just keep it rolling without it. I can talk without the visuals, and you know, we can try and get back to that. I'll work on it while I'm talking. But so the reason why high-speed machining works and what allows you to go faster. I mean, starting off with, you know, as the machines have advanced and programming software has advanced, these machines can move much faster. The programming software can allow you to do some more dynamic tool paths and different things like that. And what you would do to utilize that, you know, that ability to go faster. On the tooling side of it, what we do is we factor in a chip thinning. So chip thinning is as you move forward, and your program step over is X. You're moving forward, you know, your chip load per tooth. If you're taking a light radial cut, you're actually moving forward, but that chip is not what you're programming it.
Yes.
Radio chip thinning is what allows you to go increase your RPM, increase your feed rate, and that is kind of I would say the main thing you want to focus on with high speed machining is, or I should say, what allows you to do it. So when we're talking about tools for high speed machining, generally you're going to be looking at tools with a higher flute count, with you know, a longer length of cut. What gives this the advantage over your traditional machining where you're taking heavy cuts, you know, taking an end mill, going 1x-D, you know, heavy cut, removing the material out of a slot, something like that.
Yes.
Going to multiple flutes, going to lighter cuts, it reduces the heat that you're building up. With the lighter chip thinning, the chips are thinner, so you need less, you know, clearance in the flutes, and so it allows you to have a longer length of cut with a more stable end mill, and that's what you know, the length of cut, when you do the math on a material removal standpoint.
Yes.
Adding, you know, if you actually do the math, you might say, oh yeah, I'm taking this, you know, face mill, I got a 3-inch face mill, and I'm going to, you know, take this, you know, step this down, I'm doing 3 inches at a time, but that your RPM isn't that high, and you can't take advantage of the chip thinning because you have so much radial engagement in that face mill. You can actually beat that 3-inch face mill with a much smaller diameter solid carbide end mill by using the full length of cut, light step overs, but you're reducing the heat because you're not in that cut very long. And
Yes.
I think I know you talked about it when you're talking about hard milling, you know, how that heat reduction allows you to spin the tool faster, you know, and it also allows you to increase your chip load per tooth, because like I said, as you advance, you know, your feed rate, you're programmed for X amount of step over. The actual chip that you're creating is thinner. So in all of our literature allows you to actually add like a chip thinning factor when you're programming for these high feed, high speed machining techniques. Trying to reel myself in because, like I said, I had unfortunately I can't share my screen, but we're getting there. I'm trying to keep up with where I thought I should be. The tool selection and Also, feature selection is important to think about when you're doing high feed machining, because you can use some of the principles of high feed machining without having a special tool for it, but you also need to have the feature for it. And it really is going to help you out when you're doing things that are have a deeper depth than like the width on them, you know, or the depth to width is you know, if you're just facing, obviously you're gonna just take a face mill and go over the top of it. But once you have, you know, if you have a little tiny step, you can go in and just do it once. You know, if you have a deep keyway or a deep slot, you know, I worked for a place and we switched to doing tricoidal milling for all of our key slots, and it was a real game changer in. You know, you look at, you're like, how is this going to be faster? We're going to make all these little moves in here. You know, it feels like it's going to take forever. Well, if, like I said, if you look at the material removal rate and you do the math, it's faster. And the other thing that it really does that, you know, not just removing chips faster, it removes the chips in a far more predictable way. And it's a lot easier to have a, you know, to plan your, you know, when is this tool going to wear out? It reduces that pucker factor.
Yes. I was thinking about it just now, is if you have a gigantic amount of material to remove, you could sink a cutter so many depths, move it slow, get those big chips out, or you can zing right across and remove the same amount of material with smaller step overs and faster movement. So it's 6 of one, half dozen the other.
And it's a much more reliable process. The chips that are created are a lot easier to deal with. You're not taking, you know, an end mill. Once you get that thing fully engaged and those chips are, you're you know, a lot of times you can be running these things. It'll work, but you're running that thing at its, you know, it's almost packing up with chips. It's almost failing. You can run it to where it almost fails and it's a nice heavy cut and you can, you know, it did the thing that you wanted it to do, but that is not necessarily going to be a reliable process. You know, that tool gets dull and all of a sudden it snaps. You know, you don't, you know, if you're getting close to where your chips are packing up, especially in a closed slot, things like that, it can really, that chip evacuation can really hurt you. Whereas with high-speed machining, these chips are going to be small, thin, easy to deal with. You know, that you can use an air blast and they just, you know, blow out of there.
They're gone.
Yeah, that's something that I don't think it's, you know, when we talk about, oh, it's going to be faster, it's going to be faster. Look at your material removal rates. You know, that is for sure something, but that process reliability, you know, where, hey, listen, we want to run this lights out. Well, you probably don't want to bury an end mill in that over and over and over again.
No.
But if you want to get into that type of thing, that having that process reliability where you know that chip evacuation is going to be there, it's not going to cause a problem. That's another factor of high-speed machining I don't think, you know, gets talked about enough. And you know, having the things that are going to limit you, I think, as far as, you know, high-speed machining goes, is what you need a machine that can move fast too, and then you have to be able to program it, and you have to be able to I would say trust the speeds and feeds that we're suggesting, which I think a lot of people have a hard time with sometimes.
Yeah, I am very conservative, mostly because it's not my machinery. I'm extremely conservative with my feeds and speeds.
Yeah, and you can really, you know, I mean, I would say push the envelope with your speeds and feeds when you start using these high speed machining techniques, because you're not running that tool really at the edge of where it needs to be, like you would be doing a heavy cut, you know, a full slot. And it's better on every part of the machine tool, you know, things like that. One of the things you have to keep in mind too, though, when you're looking at this, is the geometry, the feature that you're making. You know, you can't just, if you've always taken a 1/2 inch end mill and that's how you used that, you know, that's what you're using to make a 1/4 inch radius in the side of a pocket. Well, if you try to do that and utilize a high-speed machining technique and you take that 1/2 inch end mill and you go diving into that corner, your radial engagement went from minimal to that whole thing is captured in that corner. And it's going to be a huge spike in the load, a huge spike in you know, what the forces are on that end mill, and that's where you're going to see this, you know, these tools fail. So when you're looking at a part, when you're looking at a feature that you want to try and do high-speed machining on, you have to take that in consideration, that, you know, you want to have room to move a smaller tool inside of that. You know, one of the things I was hopefully going to pull up here was just our literature has a lot of these things. You know, what size tool? You know, I think it's 75% of the width of the slot. You know, if you're going to tricoidal mill out a slot, you know, those are things you have to keep in mind. You know, if you're looking at a pocket or a you know, an outside profile, if you have an inside corner, you know, you have to make sure that that end mill is the correct radius, so that you're not, you know, just trapping it in a corner, because that's where high-speed machining is going to fail. And you go, oh, there's, you know, the breaks every time it goes in a corner. Well, you might have to actually go to a smaller end mill and, you know, do what would be called like corner picking, where you actually come in and do smaller moves in to get into that corner rather than a big, you know, 90-degree. And that's something that I think we really, you know, to focus on. And those are the types of things that, you know, after doing these techniques, that I'm going to see right away on a part. You know, if you know, and, you know, one way we can help you, you know, from I can help you or Guhring can help you, is we can help you pick the correct tool for that that application, to make sure that it's going to give you that chip thinning, and it's also going to be sturdy enough and rigid enough to you know, still be, you know, still give you that material removal rate that you're looking for.
Excellent. So my next question for you is, and if you're not allowed to name drop, that's completely fine. I realize there's a lot of proprietary names, there's a lot of proprietary information, but what would you say is one of your biggest challenges in the industry? Did you ever have to design a tool that a customer had just a terrible geometry or a process that you had to come up with? What was your biggest challenge that tested your skills?
So my role here right now, I haven't had a really good opportunity for me personally where I've been able to do that. But I will say that I am looking at our reports from our salesmen on the field, and we oftentimes, you know, we get these, and it'll be one end mill will change the process that you're doing, and it'll be, you know, a $20,000-$30,000 improvement on one particular, you know, that's just changing one tool, one job, one feature, whatever it is. You know, there's several $100,000 on a couple of them. You know, you can really do some, when you start implementing the correct tool for a job or moving into a special tool that, you know, we can help you design whatever it is, you know, whatever size. We also have a Hohlfelder line that is a you know, an inserted you know, multi-face, multi-bore type tooling, custom tooling package that we can help you with for anything. But I would say, like I said, every day I'm using my skills to help people on the phone with whatever they need. And our guys out in the field can, you know, they can get in there and see what you have and either come up with a custom solution, or a lot of these are just the correct standard tool we have off the shelf. Just either it's better for the job that you have, or it's a tool specifically designed for what you're doing that we can help you, you know, just improve your process and save time and money.
Excellent. So I want to take one step back. I had something come up. Is you had mentioned a couple times your correct me if I'm wrong. Your literature about formulas for material removal rates. Is this literature available to your customers and the public?
Oh, absolutely. Every one of our catalogs has this in the back. You can go on our website, and I believe it would be under support. A lot of these, and then you would go down to milling, and a lot of those, your different types of strategies are going to be listed in there, the parameters for those strategies on all of our tools that are meant for, high-speed machining specifically. We're going to give you a chip thinning factor. So if you reduce your rate to, like a 10% step over, that's going to be a different speed and feed for a full slot. And we give you those for our high-speed machining end mills, and also just your regular roughing, 4-flute end mills and that type of thing too. But all of that literature, again, is in our catalogs. It's online. And then if there's something that you can't find or you need help finding, again, reach out to me, and I can put you in the right direction for sure.
Excellent. So the last thing we'll go over today that I really love doing with all of my guests is to just give you the stage. Are there any new developments that you can share with the public without giving up any ghosts for sure? But if there's anything you can share or any new developments you want to get out there for Guhring, stage is yours. Let's go.
Well, there's things that that I think we have coming up that are going to be great. I can't really get into a lot of specifics on what we have coming that hasn't been released. There's definitely a lot of stuff will get released for us here. They will do a product release in Germany, and then we will do ours here, especially once we get our inch sizes built up in our system for those. I know we have. We recently just launched. We're going to be waiting on and getting inch sizes coming up. We have high feed mills that we're going to be introducing inserted high feed mills that we're going to be introducing inch sizes to as well. And a lot of these tools we're going to have on the shelf in metric, but because the U.S. market is still heavy into the inch sizes, that's the kind of stuff where you can kind of see what's going to be coming, or before we do a real product launch here, we want to have our inch size inventory built up. But we'll have a lot of stuff that's newer in metric sizes available right away.
And then this question just popped up in my head now, and I hope you can answer, Brad. Do you at Guhring have like a set timeline for product releases? Do you have like a spring and a fall product release? Do you have, or is it kind of just as things come?
I believe that they will do that. And like I said, ours here in the United States is going to be probably a little bit different because they will do theirs in Germany, and then we will do ours here. So it might be split up, and I've been here through a few cycles of that, and I believe a lot of it will be geared towards a trade show specific or things like that. Those are going to be kind of your time frames for when those are going to be launched. But if you follow us on socials and if you go to our website, we're going to be advertising those new things quite a bit. And that's probably the best way to figure out what we have coming down. The other thing would be to get in touch with a Guhring territory manager and a Guhring rep, and I'm sure they'll be happy to show you any new things that we have coming up.
Excellent. Will you guys be at IMTS in September?
I don't believe we are going to be at IMTS. At least I don't believe we're going to have a booth set up. I don't know. I think that we're not doing it this year. But I know I think we're going to be definitely at some of the European trade shows.
Okay. All right. Well, that wraps up my questions for you today, Brad. I really want to take a moment yet again and thank you for taking all this time out of your busy schedule to speak with us here at Cutting Tool Engineering. And I would point anybody looking for a good custom milling solution, talk to Brad or talk to Guhring Tool. Now, one thing I didn't get to mention today was our coffee. So being the daily grind, it is a double entente, as many of you know, on machining and grinding. And today's brew came from Black Rifle Coffee Company again, and it is their Tactisquatch Dark. and it was a kick in the pants. It was really, really strong. Very good job, guys. So thank you to them. Once again, thank you to the Lafayette EV Club for providing the spot to broadcast today. So go engineering. And one last time to Brad Kamichak and Guhring Tool for joining us on the Daily Grind. I'd like to say that may your only daily grind be the coffee in your mug. I thank everybody for watching and listening. Tune in same time, same place next week. We have our last episode in our series on milling. So again, thank you very much, Brad. Thank you very much for joining us.
Thank you for having me. Have a good one.
Bye.